Okay, welcome back to the Hoffman HF225 alignment video. We're on the receive side of this new radio, and you've got me G0OJF, otherwise known as Tango 21. And the other engineer here today is Mark G7NDJ, who's also on the CB from time to time as ZX2. I think he was into ZX Spectrum computers back in the
no, ZX80s and
ZX80s and 81s, was it?
Yeah,
that's showing that we're no spring chickens. Well, I've been doing this since 1986 professionally, and then as a radio ham as well. So, yes, right. We'll go on to the receiver. There aren't that many alignment points on this radio, as you saw with the transmitter, and presumably these four here. We've no service manual, we've no details. Mark's yawning, and we'll just see whether we can get a few more ounces of power out of this radio on receive. So we'll start with the one at the back. That would be the kind of thing what we would expect. Very careful here. It's receiving very well. The signal on at the moment is 0.22 of a microvolt. We would normally be aligning at 0.3, but it exceeds that. Whoops. Okay, knocking the signal generator off and getting it back on again. So let's just see where we go with this. So that's 0.22 of a microvolt, 0.2, 0.15, 0.1, 0.06, and then it's off my clock. So let's turn the generator off and back on again. It's still there, and it's very, very good, because some of these new sets aren't really that good on receive, but this exceeds the I think it even exceeds the Amstrad. So the next thing to do here on the receive side of things, it's got a meter on the front, and we'll set an S9 signal onto the radio, and what we'd like that to do is to hover between it's not a calibrated signal. What we'd like to see is, and it's this adjustment here which says ISS, whatever that stands for, and what we want to see is you see we can adjust that to full, so that would be S30, wouldn't it? We just want it to be kind of back one and hovering. Just there, we're just on the edge. Now if we increase the signal to a bit more than S9, it gives us a bit more than S9, and that's what we want. So that sets that up. Now the auto squelch on this appears to be a real auto squelch. It doesn't look like it's preset, but then I haven't got a circuit diagram and I don't know. So what we'll do is we'll set the squelch as usual, turn the generator off, set the squelch to threshold, which we've now done, the generator on, and it comes straight in. Now we'll adjust the squelch to full and turn up the attenuator of the signal generator till that comes in. It actually comes in at just about +30, so that's fine. That's the kind of range which is useful. Now what we'll do is we'll see what happens in auto squelch mode. We've now selected auto squelch on the front panel, and we'll see when the signal generator comes in. So we're going to switch the generator on at 0.3 of a microvolt. Well, it's done that, hasn't it? And we'll see when it cuts off. It's just hovering at 0.15 and back in at 3. I didn't say I would like the noisiness of the squelch, but it is working how you'd expect it to work. So I can't really fault that, apart from the clunky. Not as bad as the last set we were doing, that Harry Moss 325. When the squelch is in operation, it sits there going sss, and that's cheap transistors for you. Now the squelch is adjusted with the preset here, and it does say squelch at the side of that. Now what we're not going to do, you'll appreciate this is an AM/FM set. We're not interested in the AM section at all. This is going to be used solely on UK 2781 band, the 627.60125 to 27.99125, And so the AM modulation control we're going to leave well alone. So that's that. And I can't think of anything else we need to adjust on that. So thank you for watching. We'll do an on the air video later.